Hello, everyone, and welcome to our only Game Jam segment of the weekend. I'm Matt. You may know me as the host of a bunch of the Makers Arcade events that you've seen over the last 3 days. I also was one of the two people, joined with my lovely co-host, Andy. Hi, Andy, who ran a
Hey,
Game Jam last week as part of this that was focused around alt control. Andy, you want to tell us a bit about yourself and a bit about the Game Jam?
yeah, definitely. Hi, my name is Andy Wallace. I am a game designer and a member of Death by Audio Arcade, an arcade nonprofit that builds new arcade experiences here in New York. You may have seen a little bit about us earlier today, I think. We were touring Wonderville and kind of showing off some of the games we built. I like to make games that have physical components, arcade machines, or sort of other alt control stuff. And that's what this game jam was all about. So Jam Jam Revolution was this thing. Matt approached me, asked if I wanted to help with this, where it wasn't just going to be a normal game jam. We were going to have people building a custom controller for it and then making games just for that controller. So you can see a little bit of it here. I know he's got the picture up there
Mm-hmm.
too. But we had all the jammers buy this parts list that we provided that included a small Arduino board as well as some fun input devices. And we got some really basic ones, such as the button, but the exciting thing is this rotary encoder. So we got this real satisfying clicky wheel. It rotates over and over and over. Mine literally just fell out of the board because I've been using it a lot. Yeah, Matt, yours is hot glued, right?
Yeah, mine's really stuck on there. It's not going anywhere.
Very wise. And so everyone taking part in the jam bought the same parts and then watched a workshop that was presented by Mark Kleback of Death by Audio Arcade as well, and Wonderville, who again, I think you probably saw earlier, that walked everyone through building the controller. So all the jammers were creating games for this specific hardware. And this gamepad works, it reads as a keyboard ultimately, but because you can spin a dial a lot faster than you can, for instance, tap a keyboard, it really creates a new way of approaching your games. For all of the games we're going to play today, they just don't really work with a regular keyboard. So all the jammers are really taking advantage of the fact that when you have hardware that's different from what you're used to, you can really try out some new and interesting designs, which is just really, really satisfying. And I will say, just as a personal note, for me on this jam, it was really satisfying seeing folks who have never touched alt control before build their first controller, build their first alt control game. The Discord was popping off. It was really a
Mm-hmm.
lot of fun.
Yeah, it was honestly extremely like this was an idea that I had months ago of just like what if we did an all control game jam? It's like, well, that's really open ended, and everyone's gonna make a game that no one else can play. And I was like, well, what if part of the jam was you made an all control game that everyone else in the jam could play? And then there are all of these other pieces of like, will anyone actually want to do that? Will anyone want to do it enough to learn a new style of game design and also, spend some money, not much money, but spend some money on this piece? And we had a bunch of people who did, and a bunch of people seemed to have a really great time doing it. So we're going to go ahead and hop into some of the games that were submitted as part of this jam.
Yeah, let's check them out.
So shall we just go left to right? No, let's go right to left. Sin Cycle
Yeah, mix
uh,
it up.
is starting with Sin Cycle because it is a Unity executable, and so I've already got it running in the background on my machine, so it's easier for me if we start there. Um, Andy, do you by chance have like the credits doc open on your machine?
I do.
Yeah.
SynCycle was made by Travis Foss. You can find him at Meandering Leaf, all one word. So if you want to check out his stuff, and all of these games are playable on the Jam Jam Revolution itch page. Again,
Mm-hmm.
you'll probably want to build the controller to really get the best experience. More on that in a minute. But if you just want to like see more games by the folks who made this stuff, all their itch pages are there. So yep, this is SynCycle by Travis Foss.
Yeah. All right, let's get into it. And also, Travis, if you're watching, I saw you being super active in our Twitch chat today. We're actually filming this on Friday, and I saw you super active in our Twitch chat today. Thank you for stopping by.
Oh, you're breaking the illusion, Matt.
No, it's okay. It's
We're
okay.
watching the chat right now. Haha, good joke.
So, this is a game about doing laundry, and I'm hitting X I'm hitting Z and X to cycle between controlling the customers and controlling the washer itself. And now I'm gonna start spinning to try and clean this thing, but I only have 10 seconds left, so we're gonna see if I can get that cleanliness meter filled up. Come on now. Come on now.
You got this.
Come on now, buddy.
Now, shout out. Oh.
Little too slow, little too slow. We're gonna give it one more shot. Because I won't have to give the description. So this is, by the way, a great example of, like, you see what I'm doing here is I'm twisting the controller knob back and forth very quickly. I can spin it around very quickly. And this is putting in just a ton of left and right key presses really, really quickly in a way that would be kind of extremely difficult to do with a keyboard. I can even actually, I'm not too slow. I pull over here. Can you see my keyboard right now? This is me hitting as fast as I can. Oh. Well, actually, this menu is even a good example of just, like, this is really tedious. Are my arrows in camera, Andy?
Yeah, they are.
Perfect. This is super tedious. This is super smooth and clean, and it just works.
I love the, like, kind of diegetic menu here.
Yeah.
Where, like rotating the logo. I think that's very cool. And that he got, like, 3D graphics in there. I do a lot of game jams, and I'm always amazed when people, like, actually manage to do 3D stuff.
Yeah, seriously. So that is SynCycle.
Yeah. So cool. And I never quite figured out what the syn aspect was. It seemed like you were mostly cleaning things up, which seemed, close to godliness, if anything. But
and we do also have, actually, courtesy of our jammers, who are posting tons of things in the Discord as we were, like, going through this project. So we do have some sort of behind the scenes making of animations. I think this was posted, like, day one of the jam, of, like, the idea of laundry. That's spinning. Let's do it. And then we got to sort of see the graphics gradually get more and more complex as time went on, until you have the full, like, customer ring and the game in the middle and all of the mechanics in there. So, hell yeah. Hell yeah, game jams. I love this.
Yeah, so good. Thank you, Travis.
Next up, we have Spinny Gobbler.
There's kind of a sub-theme of, like, press a button to switch what you control in this jam.
Yeah. I did not expect that, but it makes a lot of sense because it lets you really focus on the spiral component. So here, you see that there is one highlighted ring. There's the red ring, and if I twist, I spin it. And if I press a button, I change which rings I'm controlling.
Yes, and this game was by Jay Ackley. You can find more of his work at jackley.com. He also did the soundtrack to Twisty Tunnels, the sort of demo game for the jam.
There we go, there we go. And so I'm pressing X here to spawn food pellets that I then have to try and steer into my little maw at the center of the screen. I did recently discover a fun exploit, which I am going to show off because I mentioned it in the Discord and everyone seemed to be having a laugh about it. All of these walls are physics objects, and if you hit them enough, they'll start to move. So here, if I really crank it.
I mean, you really had it going a moment ago. I think you knocked out, like, half of them.
The key is that you need to be dropping the balls in while spinning. You see how everything's sort of getting knocked apart?
Yeah.
If I do this right, I can just make a shoot straight into the maw from the top of the screen. Oh, we're getting there.
What's your honest high score in this one?
Oh, like 12.
Yeah.
But you see how this is accelerating.
Yes.
I love it. I absolutely love that. And I remember seeing in the Discord that the maker of the game is aware. But, it's a feature, right? It's a feature.
Totally.
It's a strat.
I like this one, too, because it feels like one of those, like, little marble games where you have to, like, get a few ball bearings to, like, rest in the right spot. Because every time I'm playing it, I'm like, oh, I got them inside. It'll be no problem. I'm going to switch to the outer one to be able to spin it into place. And inevitably, I just, like, lose everything that was in there.
Yep.
Yeah, but I mean, I play by the rules.
Sorry. I didn't mean to long press that. That was just like the muscle instinct kicked in. I'll play the rest of this round honest, I swear. All right, come on in, you. And then.
I love that Jay also did the really classic game jam thing of on day one, he was like, I don't think I actually have time to do this weekend. So like everyone have fun without me. And then like with less than 24 hours left, he was like, no, wait, I want to make a game. And he managed to get this done, I think, in like less than a day.
That's amazing.
Yeah.
That's fantastic. So yeah, that is Spinny Gobbler. Next up, we have Escape from Gnop. Oh, wait.
Yeah.
Do I? Okay, yes. Escape from Gnop.
Yep, and that one is by Mika Faw, who you can find at Ghost Maple.
Oh, whoops. It looks like I already had a game running here, but you'll see what's up. So it's Pong, except I'm not controlling the paddles. I'm controlling the ball. And my goal to try and sneak right past them a few times. Oh, okay, easy.
So you're kind of playing Kingmaker here.
A little, yeah. And I think, who do you like? Left or right?
Well, I'm gonna back left because they're already winning.
They're already winning. That is true. Yeah, let's just seal the. Oh, let's just. Oh, okay. Well, the right is pretty good at the game.
Yeah, I mean that is true.
Oh, sneak on it.
Okay.
Okay.
That looks really good.
Okay. The speed on this feels really actually quite precise. I want to get low and then. Okay. I think it's best of 7. If I recall from my earlier plays, it's best of 7. Please. Yes.
Ooh. Peace at last.
And actually, sorry, just to show the actual game page for that one, because we are showing all of them. Yes, there's good lore in this one too.
It's very
Your rectangular wardens seem a little nervous. Excellent stuff. Okay, yes, reach 7 points to escape. Excellent stuff.
I think I just put together that Nop is Pong backwards. Feels very obvious now.
I'm tempted to end with Orbato. Yeah, we'll do them in order. Orbato 8 has some unique things going for it. First off, it's written in Pico 8. And as part of it being in Pico 8, the creator, Fuzzy Dunlop, redesigned part of our controller to make it work better with Pico 8. For folks who watched the Jam workshop last week or who built their own controllers at home, you might notice that my controller has a few extra cables going in and out of it right now. And that is because Fuzzy found a way to make sure that this dial is reading at the right frame rate for Pico 8, a development language for making like small minimalist games. And as someone who was playing this game a bunch with our code and then tried playing it with their code, it's way better. It's way better.
Yeah. That's kind of night and day.
Yeah.
And before we get into it, so this one is Orbot 8 by Alex McKendry, who they actually didn't have a social media handle. They just had their email, and I feel like I don't need to just like say their email on stream. It feels intense.
So I've got a dial that is controlling the strength of gravity and buttons for jumping and high jumping. Oh, well, at least I hit that first checkpoint. So I'm going to reduce gravity so that I can go in a straight line here. And I'm going to have to... Also, I'm going to double check that the music is recording because the music in this game slaps.
It's a banger.
It's really, really, really good. I'm going to give this a few more shots.
Yeah, come on. You can get to checkpoint 3.
Okay, don't do that to me on camera like this. No. All right, I have to move my mic a bit. My audio quality is going to suffer, but it'll give me a better grip on the dial. Then the gamer lean. Up and but not too far down. There it is.
This game is, especially, once you do the controller tweak that Matt was talking about, it feels so responsive and good. Yeah. And I love the, perspective, the way all the orbs...
I was so close.
That one's brutal.
I was so close to the next checkpoint, too. that long streak of deadly floor is just savage.
That's a lot of time between those checkpoints. That's rough.
Oh,
I think Fuzzy said in the Discord that he had kind of tweaked the difficulty, A, for him, the developer, and B, for him as someone who's beaten all the Celeste B-sides.
great.
So
Great. I
he
mean, I
did.
got pretty far in Celeste too, so I feel pretty good about that.
You may have noticed, Matt, that he did do one tweak between yesterday and today, which is now instead of 20 lives, you have 900, or you have 99
I
lives.
did not notice that. I was expected to run out of lives sooner or later. I guess that does change my game plan. All right, 1 second here. I'm just confirming. Okay, yes, we are getting the music. God.
Oh, thank God, yeah.
Extremely important. Extremely important that we capture these jams for future generations.
Oh, Matt, you're good at the like zero gravity, like straight line jump. I like that strategy.
It's a lot easier with the updated code.
Oh,
Up you
when you are done giving this a go, if we have the GIF of all the levels
Yes,
being laid out,
I do have all of those ready to go. Here, yeah, let's take a look at those now, actually. So I remember seeing this very early in the jam. Not this animation, sorry. There's a earlier one. This animation where I was like, oh, someone already made a level editor. Oh, wow.
yeah.
I showed this to a friend of mine, and her response was they made helicopter more interesting. But yes, you saw at the very beginning there are a few frames of a level editor in Pico 8 using Pico's tile map system.
It does. He has another GIF of it in there,
Yes,
I believe.
I do.
Sorry.
So we're gonna go through. So this was sort of stage 2, adding the trajectory, which does make the game a lot more approachable. And this is sort of starting to really reflect the final version, although obviously the player sprite isn't there yet. Moving forward in time, more stuff going on, more stuff in the edges, and this cool death rewind effect. And then last but not least, so this game is very big. I made it to around the very end of that top column of, it looks like a 4, 5 column. 1, 2, 3. Oh man. This is a really long game, y'all. And there are checkpoints. So, get to the checkpoints. I was so close to the second checkpoint. Oh, I was so close. Oh, I was so close. We can revisit it, maybe.
It's a good game.
And last but certainly not least, we have a combo game, Chill Frog and Pong.
Let's check out Pong first and then go Chill Frog.
I agree. Let's check out Pong first.
I do love Chill Frog. So this is by Amar Rika, whose Twitter is Amar Rika. Nice, getting that actual name Twitter. That rules.
So nice using the buttons for a menu there. This is Pong. It's radial Pong. Unlike classic Pong, I'm not trying to actually knock the ball out of here. I'm just trying to keep it trapped. Oh, I shouldn't have done that. Oh, I should. Ooh. So you can rack up some big points by just sort of getting it to slide around the edge. But also, as with classic Pong, the ball is going to start moving faster and faster. Means I'm going to have to. Yep. Lost a life. That's that. And at any point, I can press X to reset or Z to come back to this menu. Let's go into Chill Frog.
I love Chill Frog.
I absolutely adore Chill Frog. That's Chill Frog. It's a Chill Frog. Buttons for this, I can rotate, and X is make tongue big, and Z is make tongue small again. And it's just a delight. It feels great. It's a great play on the mechanic, and the tongue can just keep going. I gotta be careful that I don't clip out of the level here.
Yeah, it's kind of like a puzzly getting over it kind of game.
Yeah. Now we just bring it right back. There we go. It's so satisfying. Oh my god, it's so satisfying. Ooh, I don't want to be in this corner. Okay, that's fine. We're gonna sort of. All right. If
You
I
got
get
this,
enough
Chill Frog.
momentum, there we go. And that just feels so cool to like pull off a little trick shot like that. Uh, uh,
This
ooh.
one also has quite a few levels.
Yeah, no, it's ooh. Can we make it? Yeah.
Oh, I think it's gonna work. Yeah.
Yep, yep, yep.
Nice.
How do I approach this? Okay.
Oh yeah, you got this. I think you just angle up.
I don't think
Oh,
I can get enough lift because I don't have I don't have anything to wedge against. I
oh, then
think
I guess what? Yeah.
yeah, it might be easier from this side. I want a really steep angle. There we go. Oh, I didn't get the coin. Oh, my 100% playthrough is ruined.
It's an any percent run now. Whoop. We got a little bit of game jam magic in the
Got some
corner.
game jam magic in the corner, but hey, that's all part of it,
Hey,
you know?
it's still running.
That is actually really impressive. I'm curious to see, do I click the clear button? I don't think so. Give me.
I mean, when you have a second,
Yeah, this'll work. I'll just hang out for a sec.
just Unity being Unity.
Unity being Unity. Unity doing Unity things. No!
Oh, you missed it.
Ooh, this could be trouble. This could be.
I think you're just gonna wait.
Okay,
I
yeah,
feel
yeah,
like
yeah.
Chill Frog, there's no major risk. You're just hanging out.
Okay, we're ready for it this time.
Yeah, no, you got it.
That's what
All
we
right.
want to see.
Now, can you I'm curious, if you jam your tongue in there, will it just stop spinning? Like, can you stop it?
Oh no, oh no. I don't know if you've tried just holding down the button in this game. I don't want to because I'm having a good run.
Yeah.
We actually have I think I have a development. I just pop this in here. So this is one of the earlier builds. Instead of a frog, it was something that kind of looked like this dial, which is super cool. And is literally the nub on the dial getting extended, which is super cool and super clever. But also, this can happen, and this is what would happen if I did what you wanted me to do.
Oh, I wanted while the thing was spinning and you were in it for you to stick your tongue out and try to have it catch on the geometry, unless
Oh,
that
I
would
see.
cause.
I think what'll happen is my tongue will just clip through it. But here, we can, oh.
Yo, okay, well that kind of answers my question.
All right, let's get through this.
You gotta wait your turn, Chill Frog. Yeah. That's what you get for cheating.
Chill Frog has no chill. I do want to go through some of the other assets we have from this one. We've got,
Yeah.
this is a really early demo of oh, what if I had this idea? Or, okay, well. And one of the things I love about game jams is the discords and whatnot of people just posting their weird bugs because they rushed through something because it's a game jam. And then people are gradually trying to decide whether or not those things should or shouldn't be game mechanics. We also have this very good frog. It's a very good frog. I'm a really big fan of this frog.
Great frog.
Great frog. I also have another animation here titled, I titled it for my bookkeeping, Chill Frog, What Could Have Been. I don't remember what the name for this build was.
Oh, it's like the hot dog game.
Yeah, it's the hot dog game. And I do also want to play this game.
It's good. Yeah, there's a lot of good paths forward here.
Yeah,
make
seriously.
This a 3-in-1 pack.
So that's Chill Frog and Pong. I don't think there's a reset for this. Don't do what I did. Don't try to exploit the physics and brute force your way through things.
You even knew. You just told me.
I know, but I wanted to drive the point home. There are a lot of levels in that game. Yeah, that's our collection. Thanks so much, everyone who participated in this jam. Folks who, obviously, all the folks who made these games and shared their progress with us and let us share them on stream. Hugely thankful. I also know there were a few folks who bought a controller and maybe did the workshop but didn't have time to actually make a game. That's great. You now have a controller that has like 5 custom games made specifically for that, and that's super cool. Yeah, I feel great about this whole thing.
Yeah, and a big thanks to Mark for doing the whole workshop as well.
Yes. Yes, thank you, Mark, for and you know, Mark and Andy for Ed Socks. All 3 of you sort of mobbed on getting this controller script to work. I guess I should note I came up with this idea and then was like, I don't really know how to build a controller or write the code. I need help with both those things. So thank you, Andy, for when I came to you and said I have this idea, but don't think I can own the project or do most of the explicit work, for saying, yeah, sure, let's go.
Hey, it was a good idea. And 2 other folks I do want to thank is Mike O and Luigi on the Discord, both of whom were really helpful. Those were folks who were just kind of like on the Discord, providing some help for jammers if they were like having trouble with code or the hardware. So thank you very much, Mike and Luigi.
Yes, our 2 TAs, thank you so much. What a cool thing. What a cool thing to have done. What a cool thing to have done with all these friends.
It was rad, and I'm really looking forward to seeing what folks make next.
Yeah, seriously. Y'all now have your starting hardware kits. I saw someone was already like making a like plugging the buttons that they bought into a cross stitch frame and like connecting it up to an audio synth. That's the coolest thing ever for like me and Andy to see y'all already starting to remix this hardware. And if you're interested, if you're watching this and are just finding out about it for the first time and are interested in making your own games, you know, we still have our parts list online. We still have the workshop online, explaining how to build the controllers and how to sort of get the code set up to get this thing being, you know, acting as a keyboard with your machine. It also covers, the workshop also covers a bunch of other features of this board. This board has like a light sensor and a little speaker and a little temperature sensor, and they're all
and a bunch of LEDs.
Oh yeah, and a ring of individually controllable LEDs. One of our jammers modified our code to make it so that the LEDs would light up as you twisted the knobs, which is super cool. It's a great sort of, you know, our goal with this was to make a intro to alt control game jam, and it seems like we succeeded. Because we introduced a bunch of people to alt control, and now a bunch of people have like the hardware they need to make new alt control games, and I've made alt control games, and that rules.
Yeah, that's rad.
So thank you, everyone, and
thank you so much for being a part of this.
Yeah, and again, thank you, Andy. And I guess this is the last piece of stuff that I'm recording for the IMS's MakersPlay event. So also thanks everyone who tuned in for that. I've had a great time.
Yeah, no, it's been really cool. I hope folks are watching everything.
Yeah, I guess I'm signing off now. See ya.
All right, well, I'm gonna sign off as well. All right, bye everybody. Thanks for jamming with us.
Game. This is going to be an introductory video, so if you've never touched hardware before, that is okay. And I'm going to walk you through the process of building your first hardware controller. So we're organizing this game jam so that everyone builds an identical hardware controller, which means at the end of the jam, all of the games will be playable across everyone's controller. However, I'm going to show you some tips about coding so that if you wanted to customize your controller, you can. I just want to preface this by saying that if you deviate from the code that I'm going to write today, it won't be compatible with the other jammers. So you might want to save a version of this code for the game jam. So let's get started. So, what I'm going to show you how to do today is build a controller. And this controller is going to be relatively simple. It's going to involve 2 buttons and a rotary encoder. Now, a rotary encoder, if you've played old-style arcade games, this is what you'd find on Arkanoid or What else uses a rotary encoder? Arcanoid's the only one that comes to mind. It's basically a spinner, right? It can endlessly spin left and right in both directions. And so it allows you to do really interesting things, and I'll get into that in a little bit. And we're going to use this circuit board called a circuit playground. And this is a board made by the company Adafruit, who's based in New York. And this runs on the Arduino platform. And so you might be familiar with Arduino. It's open hardware, so anyone can build an Arduino board. And everyone can use the same basically software to program these boards. So what we're going to do is we're going to download the Arduino IDE. We're going to install some supporting libraries for this board in particular, and I'll show you how to do all of that. But basically, at the end of the day, you'll be able to hook up everything to this board, and it will act as an input device for your game. What we're going to do today is make it act as a keyboard, so it's going to do some key presses, but there are a lot of different options for microcontrollers such as this. They can do mouse inputs, gamepad inputs, and it can also write things to the serial port if you want to do some more advanced programming. Really, what these things look like. So, you're going to need a breadboard. This is a prototyping surface for circuitry. This is a half-sized breadboard, and it costs $5. And you can get larger breadboards, though you won't need them for this workshop. But Adafruit has similar breadboards that are much bigger. This is double the size. So if you feel like hardware is a thing that you might want to get into, you can get larger breadboards. We also have the rotary encoder. And this has a knob that's attached to it. And I can spin this, and it can go, forever in both directions. This has 3 pins on one side and 2 pins on the other. We're only going to be using these 3 pins. These are going to be how we read the rotary encoder. These 2 are actually for a button that is included here. We're not going to use this button today, but potentially if you wanted to use this rotary encoder, you can. You'll notice that I bent these 2 pins at 180 degrees, and that's because when I put this on my breadboard, I want to make sure that they don't interfere with the breadboard holes. So if you have a pair of pliers or something, you can bend these out just to make your life a little bit easier. We'll put that on the side for now. We have a set of these breadboard buttons that we're going to be using. And for $6, you'll get 15 of these from Adafruit. I'm only going to use 2. These are nice because they come with these plastic button attachments. Like, this is actually what it is underneath. But these can just snap right on. And these have 4 pins. And I'll explain this in a little bit, but we're only going to be using 2 of these pins to wire up a button. A button is like 2 pieces of metal that when you press it, they connect together. When you let go, they disconnect. So it's simply like a wire that you're just touching every time you press the button. Really simple concept. We'll get into that wiring in a little bit. We also have the circuit playground. I'm going to spend some time talking about why we chose this board over others. Its ability to act as a keyboard is the #1 reason, but it's also got some RGB LEDs built in, which are really cool. It has this LiPo battery port, so you can run this whole project off of a battery. I'm going to walk through the circuit playground in a little bit, but it's a really great circuit board, and it's only $17.50. So Adafruit's a great company, and they make really great quality stuff. So this is really, really, we like this for this particular project. We also are recommending these alligator clips, which allow us to clip really easily to our circuit playground, right? So I can just attach it to any of these holes, and it's not a permanent connection, but for prototyping, it makes our lives really easy. Now, if you got alligator clips, we recommended an assortment of things. You can get regular alligator clips that have this on both sides, but we opted for these kind of hybrids that have a wire on the other side, so we can easily just plug them in to the breadboard. Now, if you have regular alligator clips, that's fine. Clip them to a wire and then plug the wire in. It doesn't matter, but I would recommend for this particular lab to also just have these regular jumper wires so that we can just plug things into our breadboard with wires. You can also, for those of you that might have some electronics around the house, solid core wire, you can cut and strip to the correct size. If you have stranded wire, it's not great for breadboarding because it's usually made up of a bunch of tiny strands of copper, and when you try to plug those into these holes, they get frayed, and it's not a fun time. So if you're cutting and stripping your own wire, make sure it's solid core wire. 22 gauge is probably the size, but I'm not going to get down that rabbit hole too far. These jumpers are great for breadboarding, and this is what we have on the wish list. The other thing you will need is a USB micro. Now, you might have a USB micro lying around the house, and it might be okay. But something I just want to say up front is that a lot of these cables only carry power and not data because they're used for charging things. We need a USB micro cable that carries data. There is one on the Adafruit wish list for $3. So if you're unsure if you can use your USB micro cable to program, just pick it up, and the one on the wish list will do that job. I will show you how we can test this. So if you wanted to try yours and see if it can detect the board, we'll go through that process. Okay. So with that, let's just put everything down for a second. I'm going to jump back to our website because I want to just cover a couple things before we start building. So first things first. When you go to purchase the Circuit Playground on Adafruit, this is the website you will go to. And you can see like this GIF is really cool. It has these LEDs here that you can address. And what I love about Adafruit is that almost every product on their page has a tutorial, and they have a really, really great educational section. So I'm going to scroll down here. It's going to tell you a little bit about the Circuit Playground. I know this text is really small. So I'm just going to kind of breeze through this. This is the classic version. I know they have a bunch of different ones. And what I'm going to do is go down. Here's a little video that kind of shows how it works. But what I really want is this link. Check out our detailed tutorial for pinouts, driver installation, Arduino IDE, and more. So I'm going to click on this. And this is going to be the best resource for this particular microcontroller. I've used this word a few times, microcontroller. And essentially, it's not quite a computer, but it is a circuit board that you are writing commands to. And so I'm using this USB port to give this board a block of code, and then it will continue to just run that code forever until I rewrite it. Which means once the code's on there, I can unplug it from my computer and plug it into, a USB block, or I can plug it into a battery, and whenever it receives power, it has that code loaded on. So it'll just run that code forever. So if you wanted this to be wireless, you could get, a AAA battery pack that's linked here, or a lithium polymer battery for advanced users. And you can have it be wireless, which is really cool. Unfortunately, because the code we're writing today uses this as a keyboard, you need to plug it into a computer to get it to work. So if you are thinking of a wild way to make a wireless controller for this game jam, it will not work with this code. So just warning up front. So I'm not going to read this whole thing. You have this link. If you want to go through it, you can. I'm just going to kind of breeze through the things that are important. USB port can act like a serial port, keyboard, mouse, joystick, or a MIDI controller. This is the number one reason why we chose this. The regular Arduino boards actually don't have keyboard or HID input capabilities. And so we wanted something that was an easy intro board that can also be a keyboard. So that's why we like the Circuit Playground. It has a built-in USB, means you plug it in to program it. All you need is a micro USB cable. And we'll download the Arduino IDE in just a minute. And here's some other goodies baked in. I'm not going to touch on all of these, but 10 mini NeoPixels. These are the RGB LEDs. A motion sensor. It has a triple axis accelerometer with tap detection. It has a thermistor temperature sensor. It has a light sensor. It has a sound sensor. It has a mini speaker, so it can make little sounds. It has push buttons built in, which are really hard to press, so we're going to use our own. It has a slide switch, and it has 8 alligator clip-friendly input-output pins, which means all of these clips can be used both as inputs or outputs, and I'll show you how we assign those when we code it. All 8 of those can act as capacitive touch inputs. We're not going to cover that, but that's a really cool feature. A green on LED, so you know it's on, and a red number 13 LED for basic blinking, and a reset button. So there's a lot of things on here that if you bought a regular Arduino Uno, their base model, you don't even get most of this stuff out of the box. You wouldn't get the motion sensor, the temperature sensor, the light, or the sound sensor. You wouldn't get capacitive touch. You wouldn't get a MIDI control capabilities. So for $18, which is cheaper than your Arduino Uno, you get this board that has a lot more capabilities, and it is easier to use. So if you're delving into Arduino for the first time, I would highly recommend buying this board because it just is so much more versatile. So I'm going to breeze through the next couple links here because we're not going to cover a lot of this stuff in this particular tutorial. There's 2 versions of this, and this is the difference. This tells you if you have a classic, it says classic on it. And I'm just going to verify real quick. Why, yes, we have the classic. And so if you end up with the Express for some reason, just know that there are some differences here and your code may not run. I'm not really familiar with the Express, so I don't really know what the differences are, but that's okay. So, wow, here is where everything is. So I'm just going to kind of walk you through everything. Here's all your connection pads. We're going to talk about those. Your battery connector is down here at the bottom. We're not going to worry about that. All the NeoPixels are in a circle, just inset from the pads. Accelerometer, left button, right button. Here's all your sensors kind of in the middle. This Atmega chip, this is the brain. So that's where all this processing is happening. So since we're not using a lot of this, I think we can safely skip over it. Knowing where the micro USB connector is probably important. This is how we will program our board. You can feel free to read about all of this stuff on your own time. I'm going to go through it all, but if you want to know about all the different parts, they are outlined here. Just going to kind of breeze through all this stuff. If you do need to troubleshoot this, you can go to the Adafruit page that I was just on, and there is a whole lot of troubleshooting that will help you to recognize the board. Because this website is so much better at this, if you have problems, I would maybe direct you here to diagnose them. And so I'm going to do the thing that they do here, and I'm going to load up some example code. I'm going to go to File, Examples, and we're going to go to Basics and Blink. This is going to be our the code that we run to say, is this board working? And so I'm going to keep this code in the background, but I'm just going to walk you through really quickly what the Blink code does. Turns on an LED for 1 second and then off for 1 second. Pin 13 is an LED, and so I already know this is built in because I saw that in the documentation. In the setup, we're gonna say it's an output pin, and then in my loop, I'm gonna write the LED high. I'm gonna delay for 1,000 milliseconds or 1 second, and then I'm gonna write it to be low and wait for another 1 second. So up here at the top, I have a check mark, and then I have an arrow. Check mark is going to verify to make sure my code doesn't have any spelling errors. Cool. I just opened an example, so it should be good. This will write the code to my board. This also checks it. So if you only want to use the arrow, you can. Let's see what happens here. So it says uploading, and now it says done uploading. So let me just kind of go over here. And now, see that LED right next to the USB port? That's blinking. So the blink code works. I know I can program this. And so what I'm going to do is I'm going to connect a button. And I'm going to flip back. And we're going to use the breadboard. And I'm going to take this button. And I'm going to plug it in so it straddles this kind of center cutout here. And I'm going to put this one kind of in the first 2 holes. These guys can be a little bit tricky. Make sure the legs don't bend under themselves and they actually press into the breadboard, because I want to make sure I have a good connection in here. I'm going to do this one as well. Make sure you will leave enough space. And so basically, even though these buttons have 4 pins, the 2 pins on the left are identical to the 2 pins on the right. If I hook something up to the top left, it's also connected on the top right. So what I'm going to do is I'm only going to use the left side of the breadboard. I'm going to ignore the right-hand side. But just so you know that, whatever you hook up to the top row over here is also connected to the top row over here. Same with the bottom row. But as far as buttons go, when I press this, it just connects these 2 pins together. Same here. These 2 pins are getting connected together. Now, the first thing I'm going to do is I'm going to give myself a reference to ground from my circuit playground. Now, if you've ever looked at any battery, or you've opened up a car, or you've seen jumper cables, you've seen a red cable and a black cable. Traditionally, red is our positive, black is our negative. I'm going to keep these conventions, and I'm going to use black to connect ground. I'm going to use this ground pin, the 3 o'clock ground pin. And what I'm going to do is I'm going to connect it actually to the top pin in my negative column. On the breadboard here, these holes are connected in different ways. On the left-hand side, all of these pins are connected together in this column, and that's the positive column. All the pins in this negative column are connected together. So if I want to connect anything to ground, I can use anything in this column. On the right-hand side, these are the same. These plus holes are connected together. These minus holes are connected together. However, this side of the breadboard is not connected to this side of the breadboard. So unless I actually put a wire connecting these together, I can't use this minus and this minus because they're physically not connected. In the middle of the breadboard, these are connected across horizontally. So anything I plug into this hole will be connected to the next 4 holes. And this split down the middle also divides this. So everything on this side is not connected to anything on this side. So if I want to connect something to these buttons, I can use any hole. There's 4 holes remaining. 3, because this button's a little bit bigger. But let's say I wanted to connect these to ground. I can take a black wire, and I'm going to actually connect the bottom pin to ground on both of these buttons. So you can see this is in the same row as the bottom pin of this button, and this side is connected to the ground column. I'm going to do the same thing for this blue button. Now, this means that whenever I press this button, whatever is plugged into the top will be connected to ground. So I'm going to connect those to some input pins. And I'm going to use pins 9 and 10 because they're right here, and it'll be really easy. And since I've got a green button and a blue button, I'm going to use a green clip and a blue clip. So let's use this one for 9. And this one for 10. Now, what is going on here? Basically, when I push the green button, it's telling pin 9 that it is now 0 volts. So when I'm not pressing it, it's reading nothing. When I am pressing it, it's 0 volts. Same with pin 10. I'm saying when I press this, it's connected to ground. So for digital inputs, we're dealing with 1s and 0s, right? And we want to read this as either a 1 or a 0, which means that when I'm not pressing this, it should be reading as a 1. And what is cool about this board is I can program these pins to read as a 1 when I'm not pressing them. And so I'm saying, okay, it's a digital 1 or a high. When I press this, it's a digital low. Okay? High, low. High, low. This is how we're going to read the voltage from this. We don't care what the voltage is. All we care about is that it's a 1 or a 0. So let's write some button code. So the first thing I need to do is I'm going to do this above the setup function. I'm going to just assign some variables. And this is useful because I want to know like what my button is rather than just use 9 and 10 all the time. So I'm going to make an integer, and I'm going to say button 1, and I'm going to set it equal to 9, right? That's just the pin that I used. Oops, I realized that I don't have my code visible. All right. Semicolon at the end. This is how the Arduino software knows that I am done with this line and I'm on to the next. I'm going to do the same thing for button 2. So button 1 is 9, button 2 is 10. And this is how I know what pins they're on. Okay. The next thing I'm going to do is I'm going to jump down to my setup. And I'm going to use a built-in function called pin mode. We briefly saw this in the Blink code. This essentially is how we tell our circuit playground whether we have an input or an output. So I'm going to say pin mode, open parenthesis, button 1, comma, all caps, input, close parenthesis, semicolon. I'm going to do the same thing for button 2. Now, here's the trick. This is also something that you can only do on the circuit playground and a few other boards. Remember how I said I want this to read as a high voltage when I'm not pressing it? The way I would do that in a regular Arduino is I would attach a resistor to that pin and then connect that resistor to power. And a resistor is essentially a circuit component that provides resistance to the voltage. So it's reading a high voltage, but it's reading a weak high voltage through this resistor. When I press the button, it's directly connecting it to 0. So it's saying, I see a high, it's really weak, but when I press the low, it's seeing low through no resistance at all. Now, I can turn on an internal resistor on the circuit playground just by saying input underscore pull up. It's called a pull up resistor because it's a resistor that's pulled up to the high voltage. The opposite of this is a pull down resistor. I'm not going to get too deep into explaining this. I know this is a little bit confusing, but if you write input underscore pull up, all this means is when nothing is connected to this pin, it's going to read as a high voltage. Okay. So, the first thing I'm going to do is I'm going to read the state of my button. So, even though my button 1 and my button 2 have integers that are hard-coded to 9 and 10, I'm going to need 2 more integers. Actually, I can create these down here. I'm going to create another integer in my loop called button 1 state. And this is going to be digital read button 1. Be careful of your capitalization. In the R in digital read has to be capitalized. Semicolon at the end. So basically, I'm creating another integer that's going to store the value of my button 1 every time I run the loop. So like 30 times a second, I'm going to say, is it a 1 or a 0? Is it a 1 or a 0? Is it a 1 or a 0? I'm going to do the same thing for my button 2. And now what I'm going to do is, let's say if button 1 state equals, because we're just checking, we're not setting it equal to anything, low, which is 0, right? I could put a 0 here, but high and low are the same as 1 and 0. I'm going to say if button state is low, and then I'm going to open keyboard.press X. And I'm going to put that in single quotes so it knows it's the character X. And what I'm going to do next is I'm going to say delay 1000 and then keyboard.release X. This is important because we're actually manually pressing keys with Arduino. So we have to tell it when we're pressing and when we're releasing. So right now I'm going to press this for a second and then it'll release. So let's see. Let's see what happens here. I'm going to write this code. And I'm not going to open up the serial port because I should be able to just write an X. What I'm going to do now is add another comment here, and I'm going to say check rotary encoder. Now, what is a rotary encoder? I found a website here that kind of tells us how rotary encoders work using a GIF. There's 3 pins, right? I showed them to you. One of our pins is ground, and that's going to be the middle pin. I'll wire this up in a minute. My 2 pins A and B are essentially out of phase by 90 degrees, which means that as I turn this, they are connected to ground kind of one after another and then disconnected. So like if this is pin A and this is pin B, they're getting connected to ground as you turn and then disconnected, then connected, and then disconnected. And this is kind of the pulse that you get, right? So what this means is if I turn this clockwise, A gets connected first, then B, and then A gets disconnected, then B. Then A, then B, then an A, then B. If I turn it counterclockwise, it means B is connected, then A, B is disconnected, then A. B, A, B, A. So, if I have a way to check which of the pins is connected first, is it A or B, I know which direction I'm going. So the way we're going to do this is we're going to first look at pin A. And we're going to say, okay, this blue wave is A, right? So I'm going to say, if A is high, then I'm going to look at B. If B is low, then I know I'm going clockwise because A is connected and B is not yet connected. However, if A is high and B is also high, that means I'm going in the opposite direction because B is connected already and then A. Okay? So, this is the logic here. I'm going to check one pin, and then after that, I'm going to check the other pin. Okay? So first things first, let's wire this up because we need to know what these pins are. Here's my rotary encoder. Red, black in the middle for ground, red in the top, yellow in the bottom. And I've got yellow on pin 12, red on pin 6. Sorry, I'm bad at OBS. Oh, my cat wants to go outside. Hang on. I'll let her out. All right. Okay, so back to my code. All right, so I'm not going to open up the serial port, but let's just stick this in the middle. And there we go. As I move this left and right, it's moving my cursor left and right. And then I can press these buttons and get my X and Z. So, that's it. This is going to be the code that you're going to start with. I'm going to clean this up before I post it because I'm still getting a little bit of noise on my first button. But I will post this on the itch.io page so that you have reference to it. Feel free to ask questions in the Discord. If there's any issues with this circuit, if you have suggestions on how it can be better, I just kind of wrote this by the seat of my pants. I'm sure there are some people out there who can write some better code than me. But I hope this was informative and that you're able to use this to make your custom hardware controller.